Everyone, we're a group of engineers working together on a new project, a high-tech electric plant powered by liquefied natural gas. But things haven't gone smoothly. The plant's construction is almost done, but we've hit a few critical problems.
First, we need to move massive chimney tubes into the plant, but they can't fit through the main entrance. These tubes are over 21 meters long, weigh almost 25,000 kilograms, and are too wide and heavy for regular trucks.
Second, the only road to get materials in is a dirt path, and there's a transmission line right above a tight curve, making it impossible for trucks to pass safely.
Okay, everyone. Yes, we're home. And yes, Mr. Mario is probably watching this thinking, why didn't they do a presentation like normal kids? But sir, this is not just a project. It's survival. The chimneys are stuck, the plant is blocked, and I already bought my grad dress. We need these A. We're seniors, and this is our final math mission. If we pull this off, we don't just pass, we engineer history. Our LNG electric plant is almost ready, except for one massive problem.
We hit a wall, literally. The massive chimney tubes for our LNG plant just arrived. Each one weighs 24,880 kilograms. They're over 21 meters long and 3.6 meters in diameter. Impressive? Yes. Movable? Not yet.
Look, Mr. Mario, this truck represents the real Lloyd boy that we tried to use. The tube is 21.08 meters and the platform is 6.7. It's like trying to fit a baguette in a lunchbox. Not happening.
So I thought, hey, what if we tilt it? But the clearance is too tight and the curve at the entrance is sharp. That's when we said, let's bring in the cranes. Double cranes. One on each end, lifting the tube horizontally and floating it over the gate, which honestly sounded cooler than it was, because they had to carry a 24,880 kilogram pipe like it was a pool noodle.
I'm the crane boss, okay? And before anyone asks, yes, I double checked. Both cranes can lift up to 30,000 kilograms, just barely saved. Unless Mr. Mario sneezes too hard.
Math time. First, we had to figure out the support triangle for the crane zone. The base is 40.567 meters. The height is 1.54 meters. And we had 9.61 meters marked off for fill material on one side. We used area equals base times height divided by 2. So area equals 40.567 times 1.54 divided by 2. And that gives us 31.23 square meters of needed fill. We also needed to calculate the center of gravity of the tube for balance between cranes. That involved measuring the mass per meter. Mass per meter equals 24,180 kilograms divided by 21.08 meters. And that gives us 1,180 kilograms per meter.
Okay, math moment. We had to calculate the triangle under the tube using area is equal to base times height divided by 2. I had 40.567 meters as base, 1.54 meters as height, that gives us 31.23 meters squared of filled material needed. My calculator is tired, I'm tired, and Mr. Mario is tired.
Safety here. People always say, math saves lives. Well, yeah, especially when you're carrying a 25-ton tubes over workers' heads. So, take me later, Mr. Mario. Or now. Preferably now.
Next problem. Oh, the road. Yeah, dirt path, tight curve, transmission line, like right there. We needed 8.65 meters to make the turn. We had 8. There's a transmission line and a 90-degree curve. The truck couldn't pass. Plot twist. No turning back unless we used math.
I was ready to dig out the road with a spoon. But no, Jihan says do the math, and Frida pulls out the law of cosines. But I'm like, math.
We reduced the turning angle to 30 degrees and recalculated the space needing using trigonometry and law of cosines.
C squared equals to A squared plus B squared minus 2AB cosine angle.
That allowed us to find the diagonal path and sneak the truck through.
Of course, a backup plan was much of a need, so we created a custom support exoframe that acted like a hummock, holding the tube steady while it swings from crane to crane. Honestly, I'd love one for myself.
Safety math again. We balance it with angles, dynamic weight loads, and a lot of bubble wrap. Not joking. That stuff has magic powers.
We literally did weight per meter to check stress. 24,880 kilograms divided by 21.08 meters is roughly 1,180 kilograms per meter. That's like carrying a small elephant every meter.
We also remodeled the turn with a 30-degree angle. The truck could barely sneak through, just 50 centimeters of space left. By the end, I was calculating triangles in my sleep. Dreamt of Pythagoras. He said, "You passed."
Also, we totally wouldn't have crashed with the truck if we tested everything with math and simulations.